The topic of the presentation is the math behind Lego and how it applies in education and architecture. Hello everyone, my name is Darin Pavlov from Bulgaria, and today I will show how Lego can help children learn mathematics in a fun and interactive way. Many students think mathematics is difficult because they only see numbers on paper. Lego allows us to touch, build, and see mathematical ideas. It helps us understand concepts more easily and makes learning more exciting. In this presentation, I will show examples of fractions, geometry, symmetry, coordinates, history, and architecture using Lego bricks. One reason Lego works so well is that every brick is made with very precise measurements. I used my father's tools to measure the size of the bricks. You can see the exact measurements in the illustration. A Lego stud is the Lego Brick Unit or LBU, which is the standard unit to calculate scale, align bricks, and design structures. The stud is 8 millimeters and is the distance between the centers of two knobs. In Lego, we use bricks and plates as main components. One brick equals 3 plates. After this introduction to Lego, let's jump to the first math lesson for today. Fractions become much easier to understand when we can see them visually. In this example, Lego bricks show parts of a whole. The first model represents 2 out of 3 equal parts, or 2/3. The second model represents 2 out of 6 equal parts, or 2/6. Students can move the bricks and quickly see how fractions work. Lego can also help us compare and add fractions. The first model shows 2/8. The second example shows how we can add the fractions together. 2/6 plus 1/4 equals 7/12. Using Lego allows students to physically see the pieces that make up a whole, which makes fractions easier to understand than only looking at numbers. The Fibonacci sequence is a famous number pattern. Each number is found by adding the two numbers before it. 1 plus 2 equals 3, 2 plus 3 equals 5, and so on. The sequence goes like this: 1, 2, 3, 5, 8, and so on. We can continue as long as we have bricks. The knobs on the Lego base plate are made so that when connected by one bricks, they form a 90-degree angle. If you try to connect knobs at an angle different from 90 degree, you cannot do it because the bricks cannot fit in the knobs as shown on the screen. This is why I used hinges to form the angles of the triangle. Then I connect the hinges to the base plate through the jumpers. Now, as we have the 90-degree triangle, we can explain the Pythagorean theorem. It is one of the most famous ideas in geometry. It helps us find the length of a side in a right triangle. The theorem says that a on square plus b on square equals c on square. In our example, the sides of the triangle are respectively 6 knobs, 8 knobs, and 10 knobs. Let's calculate it. 6 on square plus 8 on square equals 10 on square. 36 plus 64 equals 100. The Lego model proved the Pythagorean theory. Using the protractor, I can measure the angles of the triangle. We can measure and see that the right angle is truly 90 degrees. The next angle is 53 degrees. We know that the sum of all angles is 180 degrees. So we can find the third angle by subtraction, and the result is 37 degrees as shown on the screen. Symmetry means that one side of a shape matches the other side. If we draw a line through the center, both sides look the same. Lego is perfect for creating symmetrical designs because the bricks are arranged in a regular grid. As seen in the picture, both triangles are symmetric. I checked by measuring the third angle of the triangle, and it is really 37 degrees. A Lego base plate can be used like a coordinate grid. Each knob acts as a point on the graph. For example, A is on the fourth knob on the x-axis and the third knob on the y-axis. B is on the 11th knob on the x-axis and on the third knob on the y-axis. This leaves a distance between A and B for a brick with 6 knobs on the x-axis, and this goes on. In this example, the points A, B, C, and G form a rectangle with sides of 7 studs and 5 studs. Let's calculate the perimeter of the rectangle. 2 times 7 studs plus 2 times 5 studs equals 24 studs. I earlier told you that 1 stud is 8 millimeters. That means the perimeter of this rectangle is 24 studs times 80 millimeters equals 192 millimeters. Let's take a quick history lesson with Lego. The Samara flag is a famous landmark in my hometown in Bulgaria. It is located in the Defenders of Stara Zagora Memorial Complex. The monument was built to honor the heroes of the Liberation War of 1877-1878. It was opened 100 years after the Battle of Stara Zagora. The monument looks like the Samara flag, which was carried by Bulgarian volunteers during the war. As you can see from the photo, the flag has been torn in the fighting. It is very tall and can be seen from far away. On the top, there are bronze statues of volunteers and soldiers who fought together for the freedom of Bulgaria. I tried to estimate the size of the monument using a method that shows where it was fall using perspective. I used a pen and stood at a distance so that it looked as tall as the monument, but the ground around the monument is uneven, so I couldn't take any measurements. Then I calculate the height to be 39 meters by measuring and counting the building blocks. To simplify it this time, I will create a model using the size from a picture. You can see I built the monument with Lego bricks. The size is exactly as in the picture. This was the history lesson with Lego. Now let's have a geography lesson. I will build a Lego model that represents the Tokyo Sky Tree in Japan. The Tokyo Sky Tree is the tallest tower in Japan and one of the tallest structures in the world. Its real height is 634 meters. When building a Lego version, we cannot make it full size, so we use proportion and scale. For example, if we use a scale of 1 to 1000, every 1 centimeter in the model represents 10 meters in real life. In my model, I built tower 35 centimeters height. This means that the scale is 634 meters, which is 63,400 centimeters divided by 35 makes a scale of approximately 1 to 1,811. As a conclusion, if the teacher at school used such methods of teaching, my classmates would learn more easily.